You think nothing exciting would happen, you think it would just go like this. But what we'll see is much more interesting.
All right, let's drop it.
What we've got here are water droplets, which look pretty ordinary at normal speed, but at 2,000 frames per second. Maybe mathematician John Bush can explain to us just how a drop can bounce.
Whoa, whoa, whoa. That is so cool. And that's just going to float all the way over to here. Oh!
Okay, so you're saying that that happens all the time?
That's right. Every time a water drop coalesces into water, so every time it rains, a raindrop hits a puddle.
Rains. That's raindrops in a puddle.
Yeah, so that's billions of times a day. Why does the droplet sit without just connecting?
So there's an air layer in between the two, and it's basically it'll coalesce as soon as the drop makes contact with the bath, but it takes a finite amount of time for the air layer to drain.
Or for non-PhDs, there's a thin layer of air separating the drop from the water. But as the air is pushed aside, most of the droplet connects with the water below. But this happens so fast, the connection is actually pinched off, and a smaller droplet is formed. But why do some of the drops leap up into the air?
When it coalesces, waves are generated at the point of contact, and they sweep upwards, and they apply a force, which lifts the drop off the surface.
And then once again, it's surface tension. It has enough force that it pulls itself back off.
That's exactly right.
A tenth of the size.
This surface tension is the quality of a liquid that causes the surface layer of that liquid to behave like an elastic sheet. It's the effect that allows insects to walk on water and water drops to hold together.
Wow, that's crazy. That's amazing.
This cycle happens again and again until the droplet is small enough to be completely absorbed.
Try to get
sure.